Definition: a recurrence relation for the sequence is A0, A1, A2 and so on is an equation that expresses an in terms of predecessors okay, a n minus k dot dot a n minus 2 a n minus 1 for all integers n with n greater or equal to k, okay, where k is a fixed non-negative integer, okay. So if suppose this is a sequence a1 whose first term a1 is 1, second term is 1, that means a2 is equal to 1, okay, and for all n greater or equal to 3 an is equal to a n minus 1 plus a n minus 2, that means all an where n greater or equals to 3 are depending only on a1 and a2, the values of a1 and a2, okay. So this is a this is an example of recurrence relation, okay. So now we have to just do some problems. Okay, problem 1. Use the method of iteration to find an explicit formula for the sequence Bn, that means B1, B2, B3 and so on, okay, defined by the recurrence relation Bn is equal to 5 of Bn minus 1 plus 3 for all n greater or equals to 2 and b1 is equal to 2. So entire sequence entire sequence is entirely dependent on the value of b1. Okay, so we have this is answer. Okay, so we have bn is equal to 5 of bn minus 1 plus 3. Okay, for all n greater or equal to 2. So just we have to put this bn minus 2 plus 3 plus 3. Okay, because since bn is satisfying this relation, so for all n greater or equals to 2 in this sequence, all terms are satisfying this special relation. Okay, so what bn satisfies bn minus 1 and bn minus 2, and so all are satisfying the same thing. Okay, and in the next line we put bn minus 2 in terms of bn minus 3, and then bn minus 3 we put the value of bn minus 3 in terms of bn minus 4, and so on. So this process is called iterative process, or the method of iteration. Okay, so 5 squared into 5 bn minus 3 plus 3 plus 5 into 3 plus 3. Okay, now this equals to 5 cube 5 cube bn minus 3 plus 5 square into 3 plus 5 into 3 plus 3. Okay, fine. So this equals to 5 cube. Now bn minus 3 in terms of bn minus 4, which is bn minus 4 plus 3. Okay, plus 5 square into 3 plus 5 into 3 plus 3. Now this equals to 5 to the power 4 bn minus 4 plus 5 cube into 3 plus 5 square into 3 plus 5 into 3 plus 3. Okay, and after n minus 1 after n minus 1 steps, we get bn is equals to 5 to the power n minus 1. Okay, bn minus n minus 1 plus 5 to the power n minus 2 into 3 plus 5 to the power n minus 1 into 3 plus plus 5 into 3 plus 3. Okay, so how can we understand that this degree is n minus 1? Okay, see, in first step we have This is step 1. This is step 1. So in first step we have 5 to the power 1. No, not really that. Okay. Okay, in second step, yes, in second step we have 5 to the power 1. We actually have 5 square in the place of coefficient of bn minus 2. Okay, and in third step we have 5 to the power cube in the place of coefficient of bn minus 3. And if we continue, then this is our fourth step, and this is our fifth step, right? So this is also our fifth step because these two steps are equal. So in fifth step, here the power is number of steps minus 1. Okay, so after n minus after n minus 1 steps, the coefficient of bn is estimated 5 to the power n minus 1. Okay, and you can easily observe that this quantity is nothing but number of steps minus 1. So here we can write n minus 1. Okay, and rest of the powers are observed by similar way. Okay? So bn is equal to this. Fine. Now we are getting a GP series. Okay, now this equals to 5 to the power n minus 1 into b1. Okay, because n minus of n minus 1 is equals to n minus n plus 1, so b1 plus, if we take common 3, then we have 5 to the power n minus 2 plus 5 to the power n minus 1 plus triple dot 5 plus 1. Okay, so this is a GP series. Okay, whose common ratio is 5. This equals to 3 into 5 to the power n minus 1 by 5 minus 1. Okay, because why n minus 1, 5 to the power n minus 1? Because here from this to this 5 to the power n minus 2 terms and plus 1, so n minus 1 terms. Okay, now this equals to 2 into 5 to the power n minus 1. Why 2? Because b1 is given 2. Okay, so 2 into 5 to the power n minus 1 into 3 by 4 into 5 to the power n minus 1 minus 3 by 4. So this equals to 11 by 4, 5 to the power n minus 1 minus 3 by 4, and this equals to 1 by 4. 11 into 5 to the power n minus 1 minus 3. Okay, okay, so So this is the explicit formula for getting the terms of sequence Bn. Okay, so this is our answer. So now I am going to define generating function. Okay. So what is generating function? For a sequence, A0, A1, A2 dot AN and so on of real numbers the formal power series A0 plus A1 x to the power 1 plus A2 x to the power 2 plus A3 into x to the power 3 plus AN x to the power n and so on, okay, is equal to n is equal to 0 to infinity AN x to the power n is called the generating function for the sequence AN. Okay, if the series AN x to the power n converges to function fx, okay, then in an interval then fx is called the closed form of the generating function this. Okay, convergence means if the power series is if the sum of the power series is equal to actually a function, okay, if the sum of the power series is actually giving a function, then we call the function the power series is convergent to fx. Okay, so now one small problem to find the sequence represented by the closed form of the generating function. Generating function fx is equal to 1 minus x whole square, where mod of x less than 1, we proceed as follows. Okay. We know for mod x less than 1, 1 by 1 minus x is equals to 1 plus x cube, and so is equal to x to the power n. Okay, x to the power n. Okay, now what is this? This equals to 1 minus x into 1 minus x. Now this equals to this. Okay, so this equals to summation in this I equal to 0 to n 1 into 1 x to the power n. Okay, actually this equals to 1 plus this is square into 1 plus x square. Okay, so now we are just multiplying the power of the x's. Okay, so the coefficient of x to the power n is like this. So this equals to n plus 1 into x to the power n, right? Because here I is starting from 0 and ending to n, so the coefficient is n minus 1, so which is 1 plus 2x plus 3x square. Okay, so this function, this fx equal to 1 minus x square is actually given by this power series. So this is the concept of generating function. Okay, and some properties are sum and product of generating functions. If fx is equals to n x to the power n and gx is equals to bn x to the power n, then fx plus gx is n equal to 0 to infinity an plus bn x to the power n. Okay, and fx into gx is equals to n equal to 0 to infinity cn x to the power n. Okay, where cn is summation ai b n minus I, where I is equal to 0 to n. Now one small problem is find the closed form for the generating function. Okay, for the generating function of the following sequence. So sequence is 0 1 0 0 1 0 0 1 0 0 1 and so. Okay, so fx is equals to 0 plus x into 1 plus 0 into x square plus 0 into x cube plus 1 into x to the power 4 plus 0 into x to the power 5 and so. Okay, so we have the terms x plus x to the power 4 plus x to the power 7 plus x to the power 10 and so. So this equals to, if we take common x, then this will be 1 plus x to the power 3 plus x to the power 6 and so. Okay, now take t equals to x to the power 3, so x into 1 plus t plus t square plus t cube. Okay, now x, so this equals to 1 by 1 minus t, and which is x by 1 minus x cube. Okay, and now this sum is valid when mod x less than 1. Okay, so this is the answer. Okay, so now I am ending my lecture here.